Hello, I'm Dr. Ron England coming to you from Daytona State College, and this is part 3 of the series Beyond NoSQL. This was the attempt to create a self-saving object structure or framework, and we're now on to part 3. I should have links to parts 1 and 2 here on this page, but we're going to kind of move directly into the programming. And as we move directly into programming, this time it's not a set of PowerPoint slides, I'm going to look directly at the code inside of Visual Studio. So let's do that. First, I am now looking at Visual Studio at the XML property object class directly. And as you can see, I've actually got the class subdivided into multiple regions. So the XML serialized region itself is a region, and all the code that really supports XML serialized is in that specific region of code. It helps me find code and find operations within large objects or large classes relatively quickly. But we're going to talk a little bit about why the structure. Now, if I look at this, XML property object has a series of database operations for select. And these select operations essentially do what you would think they would do if you were familiar with the way databases operate. Now, if you remember, the structure of the database, every object had a unique ID. Not just a unique ID within the object type itself, but all the IDs of everything going into the database, because multiple objects are stored in the database, has a unique ID. So if you call the method select, it should go ahead and actually select based on the ID that is the current ID of the object that you have, especially if you pass no arguments. And of course, if you did pass an argument to select, therefore, utilizing the polymorphic capability of objects, it would instantiate a data table, find the XML, go to another class called XML Object Database, and then call its select method with that ID. And if it worked, if in this case, I'm going to call another select method, this time passing the data table over, and it's going to return a true or false to let me know if it actually worked. But if it did work, the ID of the object would be set to the ID of the object that was actually passed to it. So that in other words, it found and populated the class. And as I scroll down, you'll see that I have multiple other select methods, all still, some of them being polymorphic. One where I pass it a name. Remember that in the metadata, you had an ID and you had a name. The data was stored underneath XML data, but those metadata fields were there specifically so that you would have an easy capability of querying the data and pulling things back for specific metadata. So in other words, properties that were in the metadata. ID being the easiest to use because it's unique for every object that is in the database. But the structure looks essentially the same. I create a data table. I select, this time I pass it a string, knowing that the XML Object Database class is going to have another method for select where you pass it one thing, which in this case is the name, and then you pass the data table over. Well, this select DT, what it does is it goes and it knows the fields that should be being returned from the database, and it brings them back over and populates the properties. So in this case, the XML data comes from the XML data that's in there, and it deserializes. Okay, the parent ID, if a parent ID exists, the Z order, if the Z order exists, the name, if the name exists, the description, owner, user ID, created, all those fields that were in the table are now being brought back and populated. Realizing that this XML deserialize that occurs right at the beginning is going to populate all those other properties that are not metadata fields. So select is really straightforward. But now let's talk a little bit about why have this structured so that it actually makes calls to another object. Why not just encapsulate the methods that are in XML object database directly within XML property object? Well, the reason is that I want to separate the retrieval mechanism from the functionality of the class. The class should just know, the class XML property object should just know, okay, I call select, and somehow it knows where and how to find the stuff. And it knows where and how to find it because inside those methods, it calls XML object database. But what if I wanted to change that? What if I wanted to use an entirely different type of data structure? Well, the metadata fields I would have to keep the same because that's what defines XML property object, but I could change that underlying structure of where stuff is stored by changing out that class, which in this case is XML object database. Let's take a quick look at XML object database here. Just going to the implementation of the select within XML object database. I'm going to kind of scroll up here. Here is XML object database, and it has, and I'll actually close this down, it has insert, select, delete, and update a specific regions within the class of code. And within that I have select, and it's pretty straightforward. If you've done any database programming, you construct a SQL string, and in this case it's very easy. Select star from XML object where ID equals at ID. That's parameter. You go ahead and set the command parameters. You open up a try-catch window. You create a SQL data adapter. You fill the data adapter, and you return the actual data table that's returned if you have a positive response from this. So it's pretty straightforward, and no matter what you pass to that select, it's essentially going to work the same. And for that matter, the different methodologies that you have, there's select, but we can go over here to update. It's essentially the same thing. You construct an update, okay, with the properties. You're passing over the XML property object. And remember that XML property object follows the interface iXML property object, so that is straightforward to use. And it essentially just, in this case, updates what the fields in that database are, and it updates them based on the ID of the field. Now, one thing worth noting in this is when I do these parameters, I actually, like here, the object being passed over, which is an XML property object, the value set to the XML data is actually dynamically set by the method XML serialize. So that's important. Do note that because this is a separate object, I have to pass the object being saved to this. But understand that the structure is relatively straightforward in that I have an XML property object, which is intelligent enough to know how to serialize and deserialize itself, and it sits on top and uses another object, or class in this case, called XML object database, which has a number of static methods which actually do the saving and retrieving from the database in this case, and that single table. So I'm not going to go into the depth of how each of the individual queries works, and essentially if you were using an architecture like this, you would be able to write those methods that you needed anyway. They're not terribly difficult if you've done any database programming at all. But it is important to note that I have separated the actual database functions and methods, those things that actually access the database, from the functions and methods that are calling them, which are an XML property object. It's also worth noting that I have in the database, I have an actual method that returns the SQL connection, and it does read it from the web.config file, because in this case it's a web program, through the connection string identifier object database, and brings it back. That also is important for flexibility because I can now store my information in multiple places, but I oftentimes use multiple applications that point to the same database. Okay. One last thing worth noting, and I'll show this in the insert, is like in the insert, one thing the insert does is it actually does return back the identity of the inserted object. because the XML object table has ID as an identity field. So every time you do insert into it, you're going to get a unique ID. So it is worthwhile to note that it does return the actual ID that's there. And the other one is that the database itself has to store the name of the class of the object that's being stored. And in this case, in this specific instance, I'm storing what's called what I call the short class name. For example, if the class was string, well, string is actually system.string. Okay, so the full class name would be system.string, includes the namespace. But I am storing in the database right now just the name string, or for classes that I create, just the name of the class, not the full qualified namespace and class name. So a few things to look at, but as you can see, the code now at this point for the framework should be relatively easy to understand for just about everybody. And my next video will actually show an example of how I use this framework in a real-life application with just a sample application that I've created. So hopefully I've got good information here. Again, all this code is public, very easy to use. Okay, well, feel free to, I'll have at the end of the lectures, I'll have where it's all published when you get to the final lecture, and good programming.